Hi everyone, this is Venkatramana, Mathematics Department, Vardhaman College of Engineering, Assistant Professor. Now we are discussing about another definite integral, which one we are not able to solve directly. Those are all we are solving by using this definite integral form, that is beta function. First we need to know what is beta function. The definite integral 0 to 1 x power m minus 1 1 minus x power n minus 1 dx is called beta function, and generally it is denoted by beta of m comma n, provided that m comma n greater than 0. M comma n greater than 0. This is called a beta function. So beta function formula is beta of m comma n is equal integral 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. And this one have two standard results. First one, beta of m comma n is equal beta of n comma m. So beta of m comma n by the definition integral 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. Now here we are using the substitution 1 minus x as t. From this x is equal to 1 minus t, dx is equal minus dt. Lower limit is x tends to 0 implies x has 0 in this one, then t reaches to 1. Upper limit x has 1, so t reaches to 0. Substitute these are all in our beta function, then this one changes as integral lower limit 1 upper limit 0 x is 1 minus t power m minus 1 and 1 minus x is t power n minus 1 and dx is minus dt. We know that minus changes lower limit as upper limit as lower limit. So this one 0 to 1 t power n minus 1 1 minus t power m minus 1 dt. By the definition, what is the definition? Integral 0 to 1 x power m minus 1 1 minus x power n minus 1 dx represented as beta of m comma n. In place of x there is a variable t, in place of m there is a value n. Here observe, compare these two. By using the definition of beta, this one can be written as beta of n comma m. So beta of m comma n is equal beta of n comma m, which is called symmetric property. Symmetric property. This is one of the standard result of beta function. Now we are going to discuss one more property of beta function. That one is second one, beta of m comma n is equal 2 into integral 0 to infinity sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. So beta function we need to show in this form. For that, here we are using one result for the substitution. That one, here we are using the substitution. First write the beta function. What is beta function? beta of m comma n is equal integral 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. Here use the substitution x is equal sine square theta. Then dx is equal 2 sine theta into cos theta d theta. Lower limit x is 0. X 0 means sine 0. When sine becomes 0, theta reaches to 0. Upper limit x is 1. X value 1 in this one. Sine square theta 1. That is nothing but sine theta 1. When sine becomes 1, theta reaches to pi by 2. Substitute these are all in this equation. 1 implies beta of m comma n is equal, here limits changed as 0 to pi by 2. X value is sine square theta power m minus 1. 1 minus x value sine square theta power n minus 1. And dx value 2 sine theta cos theta d theta. So this one is 2 into sine theta cos theta d theta. Here 2 constant, write this one outside. This is equal 2 into integral 0 to pi by 2. Here a power b whole power c can be written as a power bc. Sine power 2 into m minus 1. 1 minus cos sine square can be written as cos square. So this one cos power 2 into n minus 1 theta. And here remaining is sine theta cos theta d theta. This one is equal 2 into integral 0 to pi by 2. Here the sine power is 2 into m minus 1. The sine power is 1. Bases are equal. Power should be added. Then this one changes as 2m minus 1. 2m minus 2 plus 1. 2m minus 1 theta. Similarly this one cos power 2n minus 1 theta d theta. Left hand side is what? Beta of m comma n. So beta of m comma n is equal 2 into integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. This is also one more standard result. Now we are showing the result beta of m comma n is equal to gamma of m into gamma of n by gamma of n plus 1. Further, we are using gamma function. We know that gamma of n is equal integral 0 to infinity e power minus t power n minus 1 dt. Here we are using the substitution t is equal x square. Then dt is equal 2x dx. Lower limit x tends to 0, t tends to 0 implies t value 0 means x reaches to 0. Upper limit t tends to infinity implies t as infinity means x reaches to infinity. Substitute these are all in this equation. 1 changes as gamma of n is equal integral 0 to infinity e power minus t value x square power n minus 1 dt value 2x dx. This one is equal 2 into integral 0 to infinity e power minus x square x power 2n minus 2 into x dx. This is equal 2 into integral 0 to infinity e power minus x square x power 2n minus 1 dx. This is gamma of n. Let it be equation number 2. Now in place of n I am writing gamma of m. Then what is the value of this? 2 into integral 0 to infinity, change the variable also, e power minus y square y power, in place of n value m, y power 2m minus 1 dy. Let it be equation number 3. Multiply these two equations, then gamma of m into gamma of n is equal. Left side 2 into 2 4, 0 to infinity, 0 to infinity, e power minus x square into e power minus y square, x power 2n minus 1, y power 2m minus 1 dx dy. This one is equal 4 into 0 to infinity, 0 to infinity. This one is base are equal, power should be added, x square plus y square, x power 2n minus 1, y power 2m minus 1 dx dy. This one is gamma of m into gamma of n. Now use the substitution here to reduce the value. Convert this one into the polar coordinates. Substitution is x is equal r cos theta, y is equal r sin theta, dx dy is equal small r dr d theta. And here we are converting this one into polar coordinates. So by changing into polar coordinates, we are using this condition. And here the limits, x limits 0 to infinity, y limits 0 to infinity. So we are drawing the region for that. Here x0, x axis, y axis. X limits are 0 to infinity. X 0 to infinity means we are getting x starting with 0 ending with infinity. So this is our region. This total one is 0 to infinity. Whereas coming to the y limits are also 0 to infinity, we are drawing y limits. So y 0 to infinity means 0 to infinity. This is the region. Now if you are observing the common region for that, this is the common region. In this one, radius changing from 0 to infinity. Theta, here theta is 0, here theta is pi by 2. Because of that, region existed only in first quadrant. So theta varies from 0 to pi by 2. R varies from 0 to infinity. Substitute these are all in this equation. Let it be equation number 4. 4 implies gamma of m into gamma of n is equal 4 into limits are 0 to infinity, 0 to pi by 2, x square plus y square. X square is r square cos square theta, y square is r square sin square theta. So x square plus y square changes as r square. X value r cos theta power 2n minus 1. Y value r sin theta power 2m minus 1. Dx dy small r dr d theta. Now simplify this one. This one is equal 4 into 0 to infinity 0 to pi by 2 e power minus r square. Here this one r power 2n minus 1 cos power 2n minus 1 theta. This one r power 2m minus 1 sin power 2m minus 1 theta. Remaining small r dr d theta. This one we are simplifying now. Which one can be written as 0 to infinity 0 to pi by 2. Here e power minus r square. Here if you are observing r power 2n minus 1, r power 2m minus 1, r power 1. Base are equal, power should be added. Then this one r power 2n minus 1 plus 2m minus 1 plus 1 sin power 2m minus 1 theta. Remaining cos power 2n minus 1 theta dr d theta. Here we know that r limits are 0 to infinity, theta limits are 0 to pi by 2. That means we are integrating r with respect to 0 to infinity limits, theta with respect to limits 0 to pi by 2. By simplifying this one can be written as 2 into integral 0 to infinity e power minus r square r power 2m plus 2n minus 1 into dr. This one can be written as 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. Here this one I am rewriting as 0 to infinity e power minus r square r power 2 into m plus n minus 1 dr. This one I am writing as it is 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. Here we are using one of the formula of the gamma function. Gamma of n is equal 2 into integral 0 to infinity e power minus r square r power 2n minus 1 dr. This formula we are using here for this. Then this one changes as gamma of m plus n. This one is beta of m comma n. Left hand side is gamma of m into gamma of n. From this beta of m comma n is equal gamma of m into gamma of n by gamma of m plus n. So this is our standard result. This is very useful for solving beta functions. So beta of m comma n is equal gamma of m into gamma of n by gamma of m plus n. Thank you.